I'm sorry. Hold on a second. I just dropped out. Okay, what did you say? What did you say?
We are adding this product to the concrete to basically create these air bubbles
Yes.
to improve the freeze-thaw durability of the concrete.
Right. So now and it's a reaction that's happening. Gets your air bubbles for this. When I'm pumping it, if I use it in a pump truck, are those air bubbles compressible? What will happen with the air bubbles then? Pumping it in a concrete in a pump truck.
If you are pumping the concrete, you will probably lose some of the air bubbles during the pumping, but it's very difficult here to say how much you are going to lose. Sometimes it can be 0.2%. Sometimes it can be 0.5%, 1%. It depends on a lot of different factors. So it's difficult to say like an exact number.
Gotcha. Now, do you have and that's because of the compression of the pump. What's it doing to the bubbles? Is it refining them? Is it or they're just being compressed out of the whole mix altogether?
Yeah, they are just compressed and that's it. You are not going to destroy them.
Yeah, they're just going to get smaller. They're going to displace.
They are going to get smaller during the pumping, during the pressure. But when the concrete is cast, it is basically going back to the original shape and size.
And how does it? So once it's placed, how does it do that? How is it expanding again? Is what's happening? These air bubbles.
When you release the pressure, it's like if you have how to say it, something like an absorbent material. When you are basically adding the water and then you will push it and the water is released, it's going back to the original shape. So that's something similar with the bubbles.
Okay, gotcha. Great. Now this is the sodium. You have another product that's not so corrosive, don't you? That I could use. What can you give me? Is it the 260? Is that the least corrosive one?
You mean the air trainer?
Well, I still an air and trainer. Yes, one that's not so corrosive as that because it's gonna have rebar in this product, and I don't want to.
No, our air trainers are not corrosive because we are all our admixtures or 95% of our admixtures that we are using, they are not containing any chlorides. To affect the reinforcement with the corrosion. And definitely the air trainers, they are not containing any volume of the chlorides that can. Then it's not allowed.
Okay, awesome. So can you tell me? I'm trying to specify which one. How do I tell what's doing better? The 360, the 260.
It's usually based on the local materials. So
okay.
So where are you located, or where is
Philadelphia.
Philadelphia. Yeah. So we have a lot of producers, concrete producers that they are using our product, but it depends, based on the raw materials and specific requirements. They are using different AEAs, air trainers, so it's difficult to say which one will perform better because it's based on the raw materials and raw materials quality. Yeah? So different concrete producers are using different raw materials, and based on this, we are recommending different air trainers.
Now, let me ask you this: based on pumping it, is there one that performs better as far as rebounding?
No. Everything is the same. The majority of our AEA products are just different combination of the materials to basically fit better local raw materials and so on and so on. So there is no product that if you will ask that this product has the best performance. All the products are performing similarly.
Okay, I see your point there. Now, when you determined those air bubbles came back to their original size, roughly, did you guys use it?
Mm-hmm.
Did you got some concrete samples and cut them? Perhaps is that what you did?
Mm-hmm. Yep. It's basically on the hardened concrete. If you cut this concrete and polish this concrete, we can basically see how many of these bubbles are in the concrete.
Gotcha. And you guys wouldn't have any data you're sharing with the public with that yet, would you?
No, but if you are going to Google like a hardened air concrete, you will see a lot of results on the internet.
Oh, you guys do have something like that. What should I Google? Harden what?
Hardener air concrete results.
Hardener air concrete
Or,
result.
yeah, or generally hardener air concrete.
Gotcha. Yeah, I'm doing.
And there's a lot of articles about that and everything, you know. So.
Oh, I thought you might have had something there under your products.
We don't have anything like a general available that you can share. Or if you go on our web pages, you can let me check that.
I'm there now too. I'm at your products and solutions right now. But I'll yeah, the other one they sent me to densifiers. When I just looked at it, it was basically densifiers on that when I did that one search, so that didn't really come out. But yeah, please tell me where you might have it on yours.
Yeah, I'm just looking at.
Yes.
Yeah. This is your cell phone number.
It is my cell phone. Yes.
So I will send you this link by the text message. All right.
Awesome. I appreciate your help. Thank you, Sika. Thank you.
All right.
Take care.
You.
Thank you.
Bye
bye. All right. So I'm going to keep this right here, and I'm going to jump into all the darn research the guy just called me that I've been doing. And I finally came to that conclusion that it's just bubbles that the product makes. It's your reaction, your reaction from the sodium carbonate. And this is after me doing, looking for something more extravagant to be the problem, more elaborate. It's just bubbles. You see, I'm flipping pages now as we'll go through it. I'm working my tabs over that you can't see. And he showed me just hang up with them. I looked, finding this, different data and different resources, showing you, again, your solution is just going to give you, establishing first that why put the bubbles in. It's your freeze-thaw cycle. And the problem, a lot of things he says they don't have that product. It's not in their combination to eat metals. But this is another article that an engineer out of India, I believe, was commenting on us, talking about sodium hydroxide. And that's all it is. It just creates bubbles, a water reaction. Interesting, I wanted to go one step further in this and try to find, once it's compressed, it's a fluid. And will they not bond together anymore under that compression? And that's where you get your variable bubble sizes. I could not find where they are not where they didn't create a new chemical. They have an exothermic reaction and they become a new product basically. And so therefore, while it's being compressed, it's still that new product, if you will. They exhibiting themselves as air bubbles encapsulated, or vice versa. And you're pushing them in the pump. Now, I just got finished watching some of Tyler Lay's thing. And Tyler Lay is dealing with this, and I, really think it's amazing because he's showing that it appears to have lower air content when you're taking the readings, but at the hardened, samples, cutting them apart, and freeze-thaw cycle testing he's doing, that they handle themselves great. So they'll fail your air test, but they won't fail in actual function. So here are some products. Next page over, I'm going to jump to this one. More research I was doing on it. And this one, let's see if I can go with bubbles on this one. Perhaps I can. So down here, I remember reading this one here. It's like 10 pages. You're talking about with bubbles, without bubbles, the percentages. This is showing the product scales, things like that. There's nothing really. It's just supporting what I was going to commit myself with the engineer just called me back from Sika. Sorry, guys. I'm really skipping around in my voice there. I can hear it myself. Effects of alkali additions on the mechanical, and I've hit all this stuff. Nothing there. Nothing that is coming up different. I look up BAS products. BAS coming down to the same thing. Again, their product's just going to cause your chemical reaction. It's just bubbles. Dosage. There's no standard dosage, just as this guy said with Sika. Now this is BASF on this. As Sika said, the same thing. There is no standard dosages. Um, so this is the typical, and this is what they allude to. It's how you place it. Placement matters. So if you have to pass a test, unless people like Tyler get it out there and get it and show that this stuff is stable, then we're going to be stuck on stupid. This is that Tyler's thing, and Tyler right now is the most aggressive with this. So I'm supporting that, even though I may troll him backwards with some other things. But I'm supporting that because you would think also that the pump companies would be supporting him, because this would show that you get a better consistency with pumping than you do with than without. Add the air, use a pump truck, and pump your concrete. You'll get what appears to be a tighter mix, a more strong mix perhaps, with this, when it gets around to doing the fail samples, the crush fail samples on it, being that it's tighter, although kind of contrary. The Sika guy said that they kind of expand back. Tyler says they come back too, but I think he's showing them come back, not this. You know what? I don't want to corrupt his video with my comment there. So you have to look at Tyler's video. I'll link it below when I post. So again, this is BAS product. You just saw it there. I've got a couple more tabs I want to hit on with that. This one I find very, very interesting. They're making it clear that it's placement, that you can kill your placement with it, as Tyler has shown in his charts. They fail afterwards, a lot of them do, and we know that because you just don't get that proper segregation, or you get desegregation, or you get the removal of air actually. So here's another sodium hydroxide case number reports that I'm reading on, and I'm not coming with anything that's stopping my opinion on this, my thought of this. The compression was what I really feel like the bubbles and vibration was bringing them down. The BAS guy said they came back on the end. So it's a kind of moot point if I say that the vibration of the pump is making the bubbles migrate out. That's it's in the water, but they're creating bubbles, and bubbles can be removed, right? They're air. They can be removed. So they're air content. So if they can be removed, clearly you remove them by compression and having a way to filter them out. And that could be in the form of just vibration, is what I theorized. Looking at Tyler's thing, listening to him saying they came back, I'm trying to get him to show me the cut samples to prove it. Tyler has not presented his cut samples either. Oh, correction. Tyler has presented some images. I have to go back there. So I can't. All I can do is apologize now, because I don't want to edit this video saying Tyler has not. So I apologize for saying that. It might be there. I was going over his video for about the 16th time now, only up to a certain point. Then I kept getting distracted by work. This is really profound. Sodium hydroxide within the medical stuff. It's so many things in here that you can look for. And I was trying to find the smoking gun that would lead me to show me that this could be also an issue. I found multiples of different things that could lead me down a wrong track, and I went down the wrong track. Ultimately, heat's being generated. That leads me to think, okay, how much heat is being generated? All right, what's happening with the concrete? With that heat, well, we know the concrete's about, 90, 100 degrees when it's reacting. This is creating an additional heat. What happens to that sodium hydroxide when it's put under compression of about 200 psi? Apparently, we're just getting the shrinkage of the bubbles. What I'd like to see a test done is grabbing some of this product, which I could not find, and not in a concrete format, although you would think the paste and all that is part of the reaction, that you'd have to do that to do this properly. But I'd like to see it compressed. I'd like to see some of the solution that's made compressed. And I don't know how you're going to check the air bubbles under compression. I guess you'd have to say they got smaller if you can see it. Once this product is made in mass, and then compress it. Kind of an odd thing though. This exposing to air neutralizes it too. So you got to be careful how you expose it. So this is one of the articles where concrete in practice, and this is from the National Ready Mix Concrete Association, and I'm highlighting sump loss of air content in pumped concrete will not reduce freeze-thaw durability of concrete as long as the air void system is not compromised. So this is what Tyler is concluding also. They're not now. Let me go. Is it highlighted? No. So right here, the air loss due to pumping can be determined by measuring the air content of sampling discharge from the ready mix concrete truck and at discharge from the pump. Testing concrete at discharge from the pump alongside the pump will require the most critical boom configuration that will cause the highest loss of air content. If concrete at a higher air content, to compensate for this loss is placed at the less critical, more horizontal boom. So what they're saying is that, as I asked that guy, is there a way that you want to increase it or not? They're basically saying compensate for the air loss, because you're getting air loss. They also state that this drop and vacuum is creating air loss. Well, you only have a joint, right? So the air can't go anywhere. It can create a vacuum for sure. Obviously, the vacuum is not strong enough to hold the concrete up from coming all the way out. The weight of the concrete exceeds the vacuum. A vacuum is also, in that case, would also create some type of suction action, right? So there's only limited air that's going to be in there, and air pressurizing would be coming through the joints. I don't see that really happening because this thing seals up pretty good when you're pumping your pump vehicles. It says how to prevent air loss. This is a ready mix company. It says keep concrete from sliding down the line because it's under its own weight. Ensure that there is a continuous stream of concrete within the pump and inside the pump line. So steady, moderate, rapid pumping may help somewhat to minimize air loss, but will not solve most problems. So it's kind of, I think they're stuck on not progressing as Tyler's going for, as hopefully Sika Flex will present to me, and I'll represent it to you. I'm going to post this video, and that will be a follow-up. I don't quite concur with everything here. You got this concrete shear also that I don't think they mentioned shear in here that you have to deal with, and no, they don't. That you have to deal with pumping and slumps, and yes, there is a force going on here, but as Tyler tested, he tested at the hopper, right outside the hopper. He tested from the hopper and then outside the hopper. Outside the hopper, he showed he roughly 20% loss. All right, so an average roughly 20% loss. So there's immediate loss of testing using the one of his air volume kits, or air volume kit, and might use multiple different kits there, or maybe he has one type. Nevertheless, he tested at that point, and it's about a 20% loss. And then from there on, it was pretty much balanced looking at his scales. Did I pull down his? No, I didn't pull down his video. So I made it this far. It's only 14 minutes in again, but you sliding over. So I said, let me slide this way to show you this thing here from. Hopefully, Tyler, you don't take offense. I'm using your thing here now. These are the air bubbles. Let's go right to this part of it and go from there.
That were optically clear. You can see through them. We filled them full of air entrained cement paste, and then above them we put a little bit of water. We turned them over on their side, and we hooked them up to a pump so we could increase the pressure. Over time, bubbles will rise up to the top of the glass.
This is one of those kits I showed you before. It's a different kit though. It's a smaller kit. It's the same difference. But I showed that in a previous video. It's like $40, the kind that allows bubbles to come up. But here we go.
And we're able to see them with a stereo microscope. And we can take pictures as we pressurize them. So
it's not, did he say it's from the pump vehicle? Or did he just say it's paste? So that is 11-14-11.
Pumped concrete is
Yeah, he did it.
It's exactly like we found in the lab. Even though we're getting low air content and high SAM numbers in the fresh air content, we are seeing satisfactory performance of the hardened concrete. These are the same findings from the lab with a different pump, in different configurations, different equipment, different materials in the real world. So what the heck is happening? To try to provide some insight, we did a test. We took these bottles that were about 3 inches tall, about 2 inches wide, that were optically clear. You can see through them. We filled them full of air-entrained cement paste, and then above them, we put a little bit of water. We turned them over that were optically clear. You can see through them. We filled them full of air-entrained cement paste.
So I don't know where he got the paste from.
And then above them, we put a little bit of water. We turned them over on their side, and we hooked them up to a pump so we could increase the pressure. Over time, bubbles will rise up to the top of the glass, and we're able to see them with a stereo microscope. And we can take pictures as we pressurize them. So here's an atmospheric pressure picture. We can see a bunch of well-distributed bubbles. And now we're going to
hopefully he'll talk about the bubbles from the pump. But you see this is just a random sizing.
Start increasing the pressure.
Okay, so he's increasing the pressure. Oh, I guess in his bottle. Here we go. And then taking the shots.
Increase it a little bit and they move. We increase it a little bit more and look at these bubbles. Some of them look a little bit different. Let's increase it more.
So that's the deformation of the bubbles, apparently he's going to say next. Here we go.
Oh my gosh, they're changing. Let's increase it more. Now let's pay attention to these bubbles over here. Because at this pressure step, they're around, and the next pressure step, they're gone. Where'd they go? They dissolved. They dissolved. As you increase the pressure, the bubbles get smaller and smaller and smaller, and the small bubbles, when they get to a certain size, they dissolve. This is called Henry's law. We increase the pressure again. We increase the pressure again.
Yeah, Henry's law, if you guys look it up about gases. Now, it's pressure. I don't know how much pressure he's at, but here we go.
Where did all the bubbles go?
So what he's saying, increasing the pressure. I actually, part of my research, I was sending a huge ass response to Tyler about. He said he wanted me to talk to him offline in the email. So I was working on a huge response when this guy took away all my thunder to the guy he just called. And I'm looking at his email as we're talking. He sent me a text. But I went down Henry's law, not because Tyler said it, because I actually forgot that. But then I bailed out on Henry's law because it went more gases. And I couldn't produce a gas because I couldn't get to the temperature for gassing. So I bailed. And then I went to temperatures. What can we create? I went to, what we got here? Air solubility in water, right? So I went down this line. Because we're talking about air, bubbles, Henry's law, right? But what we went to, as you can see there, we went to gases where I had a bail on it. Because I couldn't show that the gas. I could show the air, but Henry's law also deals with air and gas. And I couldn't isolate the two separately. So then I started working on the hydraulic forces again, and going to that side of it to try to come up with the compression. Well, the awesome thing is I went for the heat hydration, trying to see what kind of heat we can come up to. I looked at everybody's damn scale almost, trying to see if I can get a heat to come up. If I can get heat to come up, I can get some gases. I got another thing to add to seeing why these bubbles are why they're being compressed, and what's happening to them. Where are they going? Where are they going? That's the whole thing, because they're stuck in a pipe. They're getting out of the joint, perhaps, but they wouldn't be able to escape all of that joint, all of that together, right? It's only going to pass it for a moment. Then I thought about cavitation in the joints. What's the cavitation doing in the joints? I hit on, excuse me. So I try to see all the, I wanted to look at the chemical reactions again, the heat. I just worked this thing all about trying to figure out how I can get temperature up, to get pressure up, to then add the lower amount of pressure. I thought about sea levels where you're actually pumping. I thought of all this stuff to try to see how I can get this temperature up. So I come over here, right, and I wound up here, and I wound up at one of these places, Labtronics. All right, how does temperature and pressure affect dissolved oxygen readings? So this is oxygen, air, right? That's what I'm going for. And we get down to the bottom of this article, and it says a similar result can be attained with changes in barometric pressure. So I thought, okay, that's what I'm looking for, because aren't we inducing a fake barometric pressure by pumping? And so I get the air taken out of me in a second. If a liter of water at sea, man, you know what happened? My friend came over and gave me a damn energy pill, and it's killing me. It's killing me. It's one of these things in this, whatever it was. It's like, I'm like, ugh. It's racing my ass. So you're hearing what an energy pill can do. It's nasty. If a liter of water at sea level, higher barometric pressure is brought to the top of the mountain, low barometric pressure, you would have a greater volume of water than you, okay, so if you bring, these are the same amount of water. If you bring this liter to the mountain, you'll see the levels there, it'll increase, is what they're saying. This is because the water would expand as the pressure forces it together lessens, all right? Less pressure to keep it compressed. And so this is compression down at sea level, if you will. I guess he was saying sea level there. And now it's not. See, water is compressible based on, like, hey, got it off the mountain, brought it down below, it's being compressed. It's got air in it. It's got air in it. So it doesn't fall under the same thing as all fluids. So here we go. This is because of, all right, let's move on. The result of your, breathing would go down. Just like you heated the water as before. So there's another one. You heat the water, expands, right? And of course we turn into a gas ultimately, but that doesn't work there. But in summary, the amount of oxygen in the water does not normally change with changes in temperature or pressure. So I'm like, what? The amount of oxygen in the water does not normally change in water. Does not normally change. I'm not messing up this time voice-wise. I'm just messing up because my mind is racing. In summary, the amount of oxygen in the water does not normally change with changes in temperature or pressure. So they're saying the oxygen levels will not change based on temperature or pressure, the amount of oxygen. So, and it's in water. So I can't say that it's no longer water if I compress it out here and leave a way for the water to get out. Create something that allows air to get out rather. Then I'm not following true to what they're saying. It's saying in water. So that water must stay there when you're doing this compression. And I agree with this pumping. You can allow some escaping through the joints of the fittings of the concrete pump truck. But that air, where's it going? I have to explain where it's going. Tyler explains it as it just dissipates. The air bubbles do. I say that they've gotten so small, and that's why I was trolling a bit, that, yeah, they've been compressed, and they just broke into a smaller quantity. You compress that air into a smaller quantity, and it's not just surrounded by like an oxygen tank where you just fill the oxygen tank and you keep compressing, adding more air until you can't add any more. This does have a place to go to. The concrete, the voids between all the sands and aggregates. So it has somewhere to go. It is under 200 psi, and I'm using Tyler's chart on this. Is that, well, we don't have to go down that path. Tyler did a chart, and what he showed was that I had to keep going over it, so I kind of have his chart kind of memorized. Is that right before pumping, and right here, this is the this is A. So that's his A, before A. So it's going to be right here at A or right there. And since I have a similar pump vehicle, you don't pump out of this. It's right here, I'm assuming his A is. So the concrete came in, and right there is where he took a test. At that point, as I understand it, and Tyler can correct me, please do if I get it wrong and correct me in the comments, and I'll leave your comment untouched. And that's A. At that point, he's picking off. So before pumping, he took a reading. It's called 8, 9, whatever. But after that, you now call it the air content 5, 6. And they parallel each other. Not quite. Because this is dropped to a 6, and that's like an 8 and what? 8 and 6 something. Anyway, but they drop here. And then they stay constant going across. Now, he used students, so I have a theory that when you're rotting, you can add air and mess up the numbers. Tyler disagrees with that. Well, he didn't quite disagree. He said that, well, we follow the ASTM guidelines for it. But I can troll back and say, well, if you find, a lot of people find that this air content, ASTM's air content thing is crap. That nobody, not just the contractors don't like it, but, other engineers don't like it. So this is an awesome straight line, right? And
axis, and this data point here is where the air content started. And we lost about 20% air through the pump, and then it's constant. What does that mean? You lose the air.
All right, so my interpretation, you lose the air and it's constant. You lose it right there at the beginning. And everything else is constant. This is just, user error, if you will, for getting the air content. It's beautiful. So I'm calling it a straight line, even though he's showing the real data, which is good because he's not trying to corrupt it. But you got a person doing this, students. I'm saying it's a straight dead 5 all the way across. So even though I said that air possibly can come out at the joints, I would then say that this discounts my own statement, because this would say, you lost air at the joint. You lost air at the joint. This says, you gained air at the joint? No. So you could, but it's too minor. These numbers are too much within error. So within just, user error. So we're down 40 plus feet he made it out to, apparently. So right here is your only loss. So amending my thinking and statements with you, not of this conversation, but previously with Tyler. Where's his truck? Thought he had another shot of it. That this is where the air is constant. This is where all the loss took place. I say loss, right? You can't, on the other end, he measures at the other end here. It doesn't come back to his reading. It doesn't, you're out to 20%. That's gone. So he measures it when it's still wet. And then he measures it when it's wet and it's down to 20%. So it's below. He does the readings. He puts it in a freeze-thaw cycle, and it's coming out, passing his freeze-thaw cycles. In other words, it's not failing. So we'd have this bubble issue going on. I say per his readings, this 5 here and 5 here is what I'm calling it. Nothing's lost. Nothing's lost. The question is this lost, or simply can the meter not read it? Is it lost? I guess some is lost in vibration coming out. How much? Could you call it a whole 5? I would say no. There's a hell of a lot of compression in this reduction right here. Okay, my theory then would say if Tyler didn't take this apart and he reduced this one more time, my theory would say that if he reduced it one more time in a hard pipe, that it would look like he'd had another reduction, that a loss happened between A and, say, B, a smaller pipe. But in reality, if we know no losses happen at A, how could it would have to be back pressure coming out to lose all the bubbles. I don't see that happening. You got to get through the pumping of this. And this one is, mine's a piston one. I can't really make out what his is. It might be a vacuum type one. So the back pressure won't happen, in other words. If it gets on that side, no back pressure, which is awesome if he's got that cycle type machine. And so therefore, if he knows that he has a reading here of 5, and then he reduces it down to a 3-inch pipe, I think he did it down to whatever he did it to, down to a 3, and it reduces again in pressure, then we know the bubbles are there. They're there, especially if you can put a plastic bag around here and see if it blows up for any reason, balloons out. Then we know that no air escaped there. But now we have, or maybe put some feathers in a bag too, something real low tech. If the feathers blow around, we know air is coming through. So then we know the air's in there. They just got smaller, as Tyler states here, under compression. And they're still there. They didn't escape. And so they still are doing a job that Tyler shows in his freeze-thaw cycles. So I do want to bore you with some of my research on this, but I won't do that. I'll cut my losses and click over a couple tabs to see if I'm missing something for you. So this is right, Henry's Law. One more concrete, Portland cement, hydration. I'm going to work my way down a few more tabs again. And I'm going to read this cell phone real quickly and give you a, come on, baby, come on. All right, where am I here? All right, this is the oxygen. I was even going down that line of dissolved oxygens, you know. Is the chemical reaction causing a dissolved oxygen thing, and we no longer can read the bubbles, but they're really there, and what are they doing? You know, what's going on here? The Sika's products, we went over that. Sika sent me to, and I'll share the site with you. He sent me the thing and it says, okay, yeah, he did send me something. I'm trying to see if I can share the link that does have, yeah. Of course, Tyler knows this. This granules, I think that might even talk about in other people's other states here, other things there. I was trying all types of equations. Let me slide over. I was working on the same thing. Give you my mindset, Tyler, if you came this far. Structures of water at elevated pressures and temperatures. Microscopic structures. Where Tyler was showing his thing, I went down this path. They're using X-rays. They're showing all types of things. They are showing that, and I used over here in a scale at a 70 temperature, 70. He's in a controlled environment. He would use his own. I went all over the place with this, and the structures changing is what I kept thinking. The structures are changing, and I love hydraulics, so I want to see it change under pressure. And I get half of my cake, but not all of it. This is dealing with water structures, and this site would be NASA site on water structures. It went down in a few places. It could run me a whole bunch of places on thinking of that. Ultimately, we just need to deal with this damn structure. Here I went for, I try to change the boiling point even magically. Here's gas and fluids, as you can see. Trying to make this thing happen under pressure, and I could not create a gas with the pressure of the pump trucks that I found, the 1100 psi vehicles. They were using psi A and not psi period. The line pressures, I was trying to come up with somebody showing some crazy line pressures that I could then say, okay, what would happen with the air bubbles at this line pressure? It's experienced 400 psi also, psi gauge. Oh no, this ain't, well, that's psi gauge, but it's experiencing it also. What's happening at different distances, and this is under one of my private engineering sites. You can come there yourself and find it. I can't show you my link where it gives away my account. Let's bounce out of that then. So, worked with super plasticizers. Wanted to see what they do because they're a water reducer that can create some effects and effects. Wound up over here under pumping pressures again. Really trying to get this pumping pressure up. That was my whole hydraulic forces getting the bubbles down. You leave them alone because the only thing being done differently is we're adding pressure. It's in vibration. Frequency of the machine, vibration. What's that going to do to these bubbles? Bubbles, would that also help break them down? I believe you'd have to do that. Oh, that's what I was writing, Tyler. I would love it. I don't have access like Tyler does. He's got students and everything. Latent heat and heat evaporation. Tyler's access to awesomeness. So I would love for him to test the machine at the hopper. I would love for him to turn on a machine without pumping, let it vibrate for say 5 minutes. That would be the the max you're going to let a machine vibrate before you're going to have to cycle or do something with it. You really don't want the concrete sitting there, right? So go to the max, stop the machine, sample again. See how much air came off of your sample from the unvibrated sample to that sample. And then we can determine how much vibration comes out from the hopper in a 5-minute time. But actually, I guess you're pumping faster, recycle time. Of course, then you got the concrete dropping in on it, covering it. That's another issue altogether. But just in general, standing, how much I just want to know how much vibration removes air from removes it, because that would just be removal, because it has nothing to do with compression at that point. That's just vibration. So now you see that, and I think I have one more tab. Convert water to ice and nano. I mean, I really was going down this thing real small into the nuclear level of this thing, trying to show failure in that capacity. And that's that chart, the scale chart under pressure and temperature versions. And I couldn't get the temperature up there. If I got the temperature up here, look what we got. We got a vapor. Now I think we're more into Henry's law at that point. I would have to get the temperature, the minimum 200 degrees Kelvin. 200 degrees Kelvin. I'm not going down that path anymore. Let me bounce out of that. So, just giving you what I did there. We're looking at that. We're going to go over two more. We're looking at the microscopic view of boiling, and I couldn't get it. We're going to look at online water boiling points at 300 psi, psia, because you can get that in your pumping, theoretically, right? So, I mean, you can get that there. And then you would have to add your barometric pressure. And you'd see that you might be able to get something going on here now if you play around with this chart. Then you got your gases now. Then you got another deal about dissipating, because now you got a gas and it's being absorbed differently into the materials. And I kind of crushed on that a whole lot. And I'm about burned out. Tyler, I've been working on this in my mind all morning with work and everything else, but this has been something, as you can see in all these tabs open, it's been consuming me. I've played around with barometric pressures. For example, at sea level, we're going to get 300 psi. Our new boiling point changed though at 412 now. So yeah, you see that we lowered our boiling point. I mean, our boiling point was awesome here, but the goal changed, because now I need to change my boiling point. I'm sorry, this barometric pressure, because of this psi. Now I get rid of this. PSI to 0. Oops. Oh right, barometric pressure. So let me just reset. Okay, so there is 212. So you use this chart. I'll link you to this chart. It's an awesome quick chart. It was in the email I was sending you. I guess I can flash you my long ass email, and there's the flash of it, and it goes down further. Don't read it. So don't pause it and read it, because I'm the guy called just when I was rewriting it for the 1,000th time with this amendment and that amendment. Man, it was getting so bad. I was begging to delete it at one point for myself. All right, so now I can change the barometric pressure up to wherever you're at. Change your sea levels. And how the hell did I do that? I think I went with PSI, and I used the pump to pump pressure. Tyler, after looking at his video gun, he said about 200. So the boiling point now is 379 to get to my gases. And then I'm not really a fluids dynamic guy as far as water goes, because water's just, I found so magical. It's another thing altogether. It doesn't follow under all the other stuff. It can go another level, from there. There's actually beyond boiling, it can turn to steam, but it can roll over again into another bonding beyond steam. It's just not steam. You can encapsulate it in a container, and it will roll over to. Yeah, now my brain's frozen. But you do have another. It's not just boil off. You get steam, and that's it. You've got one more it rolls into. You guys want to troll me on it? You sure can. I will link you to it. I don't think I have it handy for you though. Let me bounce over one. I don't think I have that handy for you. And there's specific gravity of cement. I went over a concrete. All this stuff, hitting it all hard, moving back. I'll hit this one tab that I'm going to be wrong in. And yes, that was another topic I was going to do for you video on my other channel. So back to this. Last one, and I'm out, is the pump partners. So I came here, and you guys can come here yourself. They have the specs of their vehicles. So this is the PSI that made it easy. And I was sharing this all with you, Tyler, but now I'm not sending that email, man. It's grammatically going all over the place. It drives me crazy. Here's your charts Tyler set up basically doing his pumps, but I just ran this to see that you can find the reductions on here if you guys so wish. As Tyler shows, it's flat. It's A-frame, and what we got there? I'm not going to click into that. That's another video. Multiple configurations. There's your PSIs up there. 1886 PSI. Now, I don't know where that is. Obviously, the head pressure, you would think, at the motor head pressure. Now, we're down to 1100 even. We're still kicking butt with these little guys. Look at that damn thing. That's if you put it on a roof and you get it's going to be, yep, it's going to be a roof drop in. I think you pump up to it and then you go from there. You're on a roof deck. Something of that nature. I didn't look at that model, but that's what they typically look like. If I'm wrong, I apologize. If you guys go and look at it and go, no, that does something else. I'm terminating the video. I'll give links I'll load it up with links down there. It's going to take me a while to grab all these tabs. And wish you guys all success. Thanks, Tyler. I really hope they change things, man. I've got on my other channels, or maybe this one too, I talk about the amygdala. I'm really into, I consider myself a stress expert. I deal with psychiatrists, psychologists. I debate with them. They can't really side with me, but they do because they keep contacting me and trying to convince me of I might be wrong. They don't say it's hard on them because they have studies that show that everything's about Freud. Everything goes back to your mother. It kind of does, and I go with that too. And what I talk about is the amygdala first, and we have anything that we make a conclusive file on. That is, I said to you that air pump, the air mixture, I'm trying to see if I can pull it up real quick. I'm looking for it. The air volume meter, if you will. And I don't know what they're going to give me real quick. Ooh. So, damn, I'll never take one of these pills again. It's killing me. Absolutely killing me. So this is what Tyler was using basically. And I guess I had it out already on another link. And he was talking about air bubbles coming up and all. They use it actually for highways, similar to this product here. It's a little $36 deal, whatever it is, $40 typically. And this is a Hobalt company. This is what they're checking the air with, guys. Now, this one I have my bone of contention is you're aerating it if you're poking at it with this rod. You're creating a void, and then you punch the concrete in somewhere else. You're randomly doing it, but it's closing up around there, around your voids. Those are air voids. If this system is so great, I think it's only fair that you just fill it up and test it. Because in the just as you would fill up, first off, I hate the idea of the size of it. I think it's ridiculous. I think all concrete testing, not similar to how it is in the field, such as 4-inch or 6-inch, is just false data. I think it's terrible to make a 1-foot cube or 1 foot anything. Let me just so I don't limit myself to 1 foot. Anything that's not exactly what you're going to do in the field. I think it's just ridiculous. Clearly, a 4-inch sample of concrete is going to fail differently than a 6-inch thickness of concrete. wow, this is amazing. I'm going to have to listen to this video again to hear my voice, how this damn pill is killing me. Never. He said, take these, man. You got to try this. And I'm like, I tried it. He's an athletic trainer. And he's killing me. He said, you're going to want to go work out. He's right. I want to go work out, but my brain wanted to stay here. And so now you hear a human brain that wants to go race, go work out, and is trying to do something with the brain part, but the body's ready to race. This is nuts. And this has been going, I've been going at 6 hours in my head like this. He gave it to me about 6 hours ago. All right, so the point I'm making there, Tyler, about the stress stuff. So you have a conclusive file that this is the right way. I understand. ASTM. I get it. That's your, so it says, and I do say so like that a lot anyway. The stress factor in this case would be, I challenged you with my statement saying the rotting creates air. Well, ASTM doesn't talk really about the air in this, I don't think, about it creating air. So to do that, you'd have to fill this up without rotting it, test it, and then fill it up and test it. But you'd have to, the problem with rotting those, to fill it up, you'd have to level it to make it fair with the original test. And then when you rot it, now you've just displaced product that's going to come out. You've also compressed it. You're making a different product when you're compressing. When you're compressing and rotting. I don't, and depending on the speed you're riding at, those forces too, Tyler, you're a structural guy. It counts, right? Work equals force times distance. How fast are you riding? You're creating a force. You're striking the surface. You're penetrating it. You're forcing everything else out of the way. And I think that stuff adds up. When they're installing it in that field, nobody's rotting the concrete. You might be tamping it, rarely. You might get a roller top tampered surface. Well, not highways, exceptional highways. That stuff is awesome. The new roller vehicles. I digress. I'm out of here. But Tyler, I attacked you when I attacked that because that's what you're using. And then you gave me your source files telling me this is why it's okay because it's ASTM. I in turn respond back to you and say why I think it's wrong, and you in turn say why it's wrong that they should accept air stuff. I agree with you. I'm not asking you to support me on this. I'm just saying that perhaps you can do some testing on that with all your awesome testing. Catch you guys. Sorry about the long video.